So welcome. This is a really interesting session. Actually, I've had a lot of fun bringing this stuff together for this, and we're going to be talking today around AI agents for this space. You'll find that there's quite a lot that we're going to cover. Those of you that have been on this before, you'll see some similarities, but to other stuff, but it's definitely got some new stuff as well. So for those of you that haven't been here before, Product Foundry has been set up to enable the community to learn AI coding. It's such a fast-moving space that it's hard to keep up with it all, even when you're sort of doing your best to kind of keep on top of it. And this community is set up as a way of people coming together and sort of learning what's going on in the space. So really glad to have you here, and hope you guys can jump in and enjoy it and learn some stuff. Today, we're going to be learning about AI agents, and basically, without trying to sound over the top, the more I've got into this, the more I'm like, if you don't know what's going on with agents, you're really missing out. There's a lot that you can do with them, and it's not at first glance obvious, like everything that you can do with AI agents. So in this session, we'll be taking you through how to use agents from a coding point of view, and it is quite a tech-heavy discussion. This one, this video is being recorded, and it will be made available on the video channel at the end of this. So if you want to sort of go through it a little bit slower, feel free to. And of course, if you want to reach out to talk to me about this stuff, then feel free to do that as well. As I said, Product Foundry is set up to help people learn how to AI code. We have a number of courses. There's some peer support sort of stuff set up. We run hackathons. There's a range of resources that are available as well. So if you guys want to learn and you're looking to sort of find resources, then this is set up for you. The Product Foundry site itself has access to a lot of these resources. And I'll just quickly jump across to there so you guys can see what's on that site, and we have an update to the site coming soon as well. So what you'll find on the Product Foundry site will be a link to the events, a link to the community guide, which I'll take you through in a second, a link to the Discord chat. You can volunteer if you want to, and newsletter, video channels, and whatever else. So those are the main resources that you'll find. There's quite a lot of information in all that. We're going to run a sort of a familiar session. It's actually going to be more focused on taking you through some of the specifics of a tool called RuCode, which is an AI agent code today. But we'll have about 20 minutes at the end to wrap up. And as always with these sessions, if you have some discussions, if you have some points you want to bring up, feel free to reach out and put it in the chat. And I'm happy to take stuff live. I'm going to turn the video off now, so you won't see my face anymore, but you'll be able to see the screen a little bit better. And yeah, we'll kick into it so you know. So that's what the sort of the plan is for this session today. Just a little bit about myself. I am 25 odd years now in this space, a PhD in artificial intelligence back when sort of first came out. I've done work over the years working in with clients like Siemens, Nestle, big banks, developing APIs, developing data platforms, developing AI applications, a whole range of stuff. For many years, I was hands off, managing teams of people doing this stuff. And with AI, it's suddenly like it's all accessible. So I've come along and sort of taken the opportunity of AI coming along to learn. And right now, I'm working on a multi-billion-dollar project building a road down in the south of New Zealand. That project is doing some really cool stuff. We've got some really cool data platform stuff on there. I've previously worked with Siemens, developing their blade inspection systems that takes all their entire fleet of turbines the drone data from the inspections of the blades. It's a lot of data, and it's all for the process with machine learning, which is pretty cool. And then worked for Nestle a little bit further back, doing work with them, and that was cutting edge machine vision at the time. So a whole range of different things. But then AI coding came along, and I've been managing teams. I've done the technical work myself. I've managed teams for a long time, and with AI coding, it's different. You need to sort of relearn again how to use all this stuff. So with anything that you're looking to learn, this community is set up to take you through the steps. So basically, if there's something which is new and exciting and kind of complex, and AI coding, for all of the fact that it makes it easier, is complex. First of all, you need to go through the thing where you're showing what's there. So you've actually, you've heard of it. You kind of know it's a thing. The next thing is to see someone do it with some instructions. And the intent of this video is to give you guys the instructions so you can follow along. We record these videos so that you can go back over that and you can actually look at the video at a time. And I'll show you in a second on the community guide the instructions that come with that. Conscious effort is where if you go away from this and you actually want to apply this, you will need to, give it a crack yourself. So that's where we've got these guides that you can do it, and you should be able to follow the guides with the video and kind of do something similar to what I do on these videos. And then as you go, you kind of move up the curve. Where you go up to depends on kind of where you are, but it's basically with the tools now, you can really get to a proficient level relatively fast, which is cool. The research is really clear in that what we've got with AI, or what we've got with any learning for that matter, is that the research sort of shows that if you learn in groups, you'll learn best. So that's why one of the reasons the community is set up. If you learn deliberately, again, we've got some hackathons so people can come on and practice stuff. We've got some coding challenges that you can track and tackle. And you can jump on and you can sort of work with one another to get some feedback. So this is kind of group is set up to help people learn. And this video or this session that you're on now is just one of the ways in which we're looking to do that. I'll just jump quickly now across to back to the website and to the community guide here, and you'll see in here that we've got a whole lot of information here. So there's information on the session notes that you'll find in here. So you can jump in, for example, and see some details on how to set up MCP and how all that works. There's details on databases. We try and capture as much as we can in here. We're running a number of sessions at the moment each week, so there's not everything is up here. And but you'll find a whole bunch of stuff. There's also the information on the tools that we recommend in here as well, which I'll come back to in a second. So the community guide's a great resource that you'll find that will help you going, and then hopefully between that and this session, you'll be able to replicate what's been done on these videos. The other place you can go to get some help is the Discord. I'll drop a couple of I've dropped the invite into the chat. Suggest you guys do join that if you haven't already. And if you're wanting to learn as well, there's a couple of channels set up to help you do that. So collaboration opportunities, learning buddies, expert advice, and volunteers. They're all kind of good places to go and all that stuff. We're going to be using Visual Studio Code today because the tool that we'll be using, which is called RuCode, works only in Visual Studio Code. In general, if you're doing AI coding, these are the platforms that I recommend. If you're brand new to the whole thing, have a crack at Firebase Studio. We'll be running a session on that in coming weeks, so take people through how to use that. If you're sort of a experienced software developer, or you're wanting to get into it in a more serious way, jump into one of these items. Probably going to need to add Claude to desktop to this soon, because it's actually starting to become quite a full-featured development environment in and of itself. But yeah, Visual Studio, Cursor, Windsurf, can't really go wrong with those. Personally, Visual Studio Code is what I use, and it's what the RuCode installation requires to sort of work with. So we'll be using that. Most of you have probably used something like Copilot to do your coding in, and Copilot's great. The kind of next level up from something like Copilot is an application called, the AI autonomous coding agents, and Klein and RuCode are examples of this. Client is the one that first came out, and RuCode is a fork of Client. RuCode is more cutting edge. They're more willing to sort of work with the developer community, so you'll find that it's sort of moving faster. You'll find it's also not as stable because of that, but that's okay. It's actually, the problems get fixed pretty quick. Personally, I think RuCode has come along in quite a big way, and but what these agents are, and we'll just have a flick across to Visual Studio for a second to show you this. What they are is installations that you put in place here. So you come in and install an extension. In this case, it's RuCode that you need to install. If this wants to work, so it does. But once you've installed it, you'll get this up there, and then this is actually Client across here. You click on that, and you'll get you get RuCode running. It looks different to things like Visual Studio, like Copilot, which you can also run at the same time as running Client or RuCode. But there's benefits to running this, which is able to run more instructions with less sort of input, provided you've set things up correctly. So it's an extension to Visual Studio Code. You communicate with it in your natural language. It reads and writes files directly to your workspace, runs terminal commands, automates browser actions, and integrates with any sort of compatible model, which I'll show you in a second. The really cool thing about RuCode, and what the session today is going to be focused on, is the fact that it's extended, and you're able to actually set up a whole bunch of automated tools using it. So, summary: if you're looking for the most stable, go with Client. If you're looking for the most awesome, which is what we're going to cover today, go with RuCode. And in general, it's pretty sort of simple to install that. The thing we're going to be covering today is something in RuCode which is called Orchestrate mode. And I'm actually, just to cover this, I'm going to jump into a visual to give you an idea of what we're talking about here. Generally, when you go to sort of code a task up, once you get to a serious task, you need to kind of have it split up into different areas. So you can sit and you can type into a Copilot or something, do this or change that or use this file or do whatever else. But if you're going to do anything in a serious way, you need to actually have some way of planning it, and then you need to be able to split it out into different tasks. One of the things you find when you plan stuff, and the previous sessions we've run on here that talk about should have shown you how to plan stuff, is that you still have to go back and kind of prompt the system quite often to go and get it to do things. And your system is set up usually with one sort of LLM or model that you need to then manually switch between. What you can do with RuCode is you can set up a bunch of prompts that give you a bunch of different modes that you can run, and those modes are sort of quite clear in terms of how they're specified. You actually I'll show you the code for that. And the really cool thing from my point of view is that you can then actually assign a model that suits the level of complexity that you're looking to do. So this particular structure that you see here, this is obviously designed for coding. And I would apply different sort of models to these different categories. And let's just have a quick look across at what this looks like. So if we come back into here, and I'll expand the screen in a second. What you can see here is RuCode running here. And then we've got a number of different modes that we can run from RuCode. So out of the box, it'll give you the ability to have a mode which is code, architect, ask, debug, and orchestrator. And orchestrator is the mode which is the most interesting, because orchestrator is the one that then lets you split stuff up into separate things here. When you run, like when you sort of set that up, when you're running code, you can actually set up the configuration to be the API that you want. And then when that goes and runs your prompts, which you set down here, you'll notice that hopefully you guys can see that. You'll notice when I change the mode, the model changes as well. So you can set that sort of things up to have a whole range of different models. And this becomes really important when you're looking to do AI coding in a serious way, because it costs money to run these things, and the cost of these things is quite different. So we'll go back in a second and have a look at that and what that actually looks like. But what you've got with RuCode here is, with the architect mode, we've got this prompt that it's got, and that prompt is specific to the architect mode. For the code mode, there's a different prompt in there, and you can sort of set things to be as detailed as you want. The prompts do get quite detailed at this level, and it's so actually what you're saying in this case is, this is the mode I want you to run. You're going to run, I'm going to switch you across to running the architect mode, for example, and I know then the prompt that's running. I can create custom modes in here, so I can come in here and I can give this mode like a test mode, and I can give it like a you are a system outputs documentation. You can give it access to different tools and stuff, and you can give it access to different modes. So when I create that mode, I now have that available from the modes that I can run. And then when I'm running tasks, if I want to, I can switch to those tasks. So this is the beauty of RuCode, of that you've got these ability to sort of set your different categories like that. If you set your categories to have these different types of tasks, you can say, I want you, this diagram is sort of shown from low complexity through to high complexity. So I would set this mode up, and I would give this the ability to do, this has been set up to do simple tasks. And you would then say, you would give that a relatively low cost LLM to work with. This one, you might give it complex tasks, and you give it a high powered but more expensive LLM to work with. And the orchestrator is the thing that makes all this happen, because the orchestrator is the bit that actually will divide your code up. It will go through and help plan it out, and then split it out into these different modes. So that's what's really cool about this. So RuCode, which is also known as Boomerang Task, will break down complex projects into smaller manageable pieces. And it's then sort of hands them off to specialized assistants. So if you're doing complex stuff, which coding is, and you kind of can split your task out and have a dedicated prompt that runs that, suddenly it becomes a lot faster to develop all this stuff. The process is to set up your modes, and we'll show you some shortcuts for that in a second. You then create a large task, it breaks it down into focused subtasks, and then it will delegate the subtask to the appropriate mode. Now, people have thought about this quite a bit, and they've said, well, what would be the best way to go about doing this? And the best way to go about doing this is not to go through and have everyone write their own prompts right from scratch. It's to give you some stuff out of the box that you can run, and then you can refine it from there. So there's a model out there which is really cool called Spark, and Spark stands for Specify, Pseudocode, Architect, Refine, Complete. And this is a framework in which to develop. And if you go into RuCode and install the different things for that, then you can have this running out of the box. We'll show you how to set this up in a second. Someone's been kind enough to go and set up a project called Create Spark. And what we're going to do is go into this empty kind of file here. You'll see that there's nothing. Don't think there's anything in here. And we'll come into here, open up a terminal window, and we'll run this command. What this will do will be it will install these modules down the side, and we'll have a quick look at what we've actually got here now. So what we've just installed in this point is a bunch of room modes. Now, room modes are, if I go back to this this list of options that I've got here, I now have a whole bunch of different options that I can go and work with, and hopefully you guys can see that. But we have orchestrator, we've got tester, security reviewer, documentation writer, system integrator, deployment monitor, optimizer, DevOps, Spark tutorial. So that's an interesting one. Superbase admin, specification writer, MCP integration, and Spark orchestrator. So this one command will go and install this room modes folder. That particular file has a certain format. And the format is, that you can see here, is slug name, role definition, custom instructions, groups. And this is sort of set up out of the box to install all the stuff. If I want to come in here and install my own additional one, all I need to do is edit this file, and I can install a different type of let's call this UX or visual designer. Now it's a slug, so it needs to have the right format, visual designer. And then we'll give it a role definition. Give it a custom instructions, give it some specific instructions to follow. And then we give it some groups to be part of. So as simple as that, and there's a bit more to it, but as simple as that, we'll now have, yeah, I haven't saved it as well. Might need to refresh some. I might need to actually set the rules up. So now I've set up the custom modes, and then you need to set up the rules in here. And this is what that command does out of the box. So it will set up all the rules for these different types of approaches in here. So what we've done, we've run this one command, and the Spark kind of framework is the specify pseudocode architect refine complete. But what you actually get out of the box is a little bit more than that. You get this specification and pseudocode architect code, testing, debug, security review, documentation, integration, post-development, optimizer, ask, and DevOps. Some interesting ones in here, actually. The security reviewer is kind of cool. We'll go back and look at the code and see if it's set up to be doing the things that it should be doing. And of course, what we have at the top of all this is the orchestrator that will actually split these tasks out into these different modes, and then those modes will go and do stuff. So we'll jump into the code now, and we'll actually run some stuff, and we'll see what it comes out at. And we'll keep it at a fairly sort of high level, because we don't want to do anything too much at this stage. We are running on, we want to start off in Spark Orchestrator. It's using Gemini 2.5 Flash. And we're just going to run that and say, design for me that's a simple manual page. There's some information about, of course. Because this is set up to use that Spark Orchestrator, this is now going to start working through that process, and we'll see what's happening here. So the user wants a specification for an Next.js landing page for a course. So it's starting to write the specification at this stage. And what we can see here is, because we're going through the Spark process, the very first thing it did was to write that landing page specification. We've switched, if you can look in the thing down the bottom, we've switched to specification writer. And at this point, we're writing pseudocode, and the specification writer is the writer which was there to do all this stuff. And we'll have a look at that code in a second. You'll see now that it's come back from a subtask, and it's come back and it said it's finished that subtask. So what is happening right now is that Orchestrator has split some tasks out into stuff based off my one-line prompt. It's then gone away and said, I think that task belongs to, in this case, the task belongs to specify. And out of specify, it's then chosen to send that to the specification of pseudocode writer. But basically what it's doing is splitting the tasks up based on the rules that you define. And if you define the rules correctly, you'll get your code sort of flowing through in the right way. And when we come back here, we can see that this is continuing to run. We're now actually getting the pseudocode being written out in a bit more detail. And we gave it like a single line of code to work off here, and now it's going away and doing a bunch of stuff. The pseudocode that we're getting out, it's actually a really useful way of doing this because it's a much easier way of checking that you've got the right kind of thing, the right sort of code set up. So if we just have a quick look at what's coming out here, the landing page spec from our simple prompt was must have a call to actions and content loading. Now we could stop this at any point and kind of update it and say, actually, this isn't quite right. I want to add more information. But we're going through the design of something the right way. We're going through, in this case, sorry, it's not quite what we did. We're going through this this process here. And it takes, obviously what it's doing is not a trivial thing. So it takes a little while to do all these tasks. But it gets to a point here where it's actually got a question for us. And so it will stop and say, are you satisfied with this architectural plan? Are there any specific areas you would like to improve? And at this point, we can, we've got a pause here. We can go back and we can sort of say, no, I'm happy. Or let's refine the data fetching strategy, or we can put our own kind of natural language thing back in here. But in this case, I'll say the plan looks good. Let's keep going. And now we'll kind of go on with the next level. So again, at this point now, it's going to start to put in place the architecture. So it had the spec, getting an architecture with our, with our folder structure that we're looking for. And we're just working our way through this process. The really important thing in all this is that when you actually go and look at the code that's behind this, and of course you can install this out of the box, just the way I just showed you. When you look at the code that's behind this, it's kind of obvious why it's working the way that it is. So the specification docs writer, we don't have this problem of it. I'm going to keep trying to jump across to the other. So you could write whatever rules you want for this. In this case, someone has written these rules and has taken the time to write a really sort of well-crafted prompt. So this is the trick to AI coding is that you need to spend your time writing well-targeted prompts as opposed to spending your time writing code. And if you can then reuse these and you know that they're going to be good, you get consistent results. So you are Rudox, an autonomous documentation specialist. You create, improve, and maintain high-quality markdown documentation, which is fantastic. All documentation must be in markup. Now, I guarantee you that these prompts have been refined over time. As things don't work, someone will go back and fix stuff up or say, this is what we must do. But you'll see here, this is not a trivial prompt. This is a pretty specific whole bunch of detail. And it's, the more precise you can be in these, the better you can be. Probably what's worth pointing out to you, though, is that these are not difficult to develop. So if we jump into ChatGPT for a second, and we say something as simple as, we want to write a documentation. We want to write a prompt for documentation writer mode for an AI video engine. Give me a prompt that is comprehensive and covers as many areas as possible. Okay, so we'll use AI to write the prompts, and then I'm actually going to show you running this prompt through, in this case, we'll run it back from another AI, and we'll get some more sort of some clarity out of that. So we're writing all this stuff in. It's giving us a reasonably good prompt, and then I would say, please give this to Markdown, and we'll get this in Markdown. We'll just jump back to here and just see where this coding agent has got to, because I'm not sure where they're actually at. Okay, so it's run into an error of some sort. And now it seems to be back. So it's hitting a few errors. We're actually now at the point where it's writing some code down here, I can see. We've got some components coming together. We'll be able to run this in a second and see what comes out of this. And we've done, like literally we've done our prompt, and then we've kind of gone from there. So anyway, so back on this, we've got our prompt here. And then I'm going to copy this, and I'm going to take this across to Gemini. Yeah. And what I'm going to say to it is, here is a prompt for documentation running. Please review and advise on how to improve this. And Gemini will then go through and be like, okay, what's the gaps in here? Where does it sort of need some additional work? And we'll come back and see what that looks like. And then we'll feed that back into ChatGPT. And you sort of go back and forth like this until you get to a point where they say, you know what, that's really good. And then you're like, that's good. So encouraging, excellent, and a very comprehensive prompt. Comprehensive structure, potential areas for improvements, initial expectations. So we've got some ways we could improve this. What it says here is your prompt is already very strong. These suggestions aim to make it more robust. And so, okay, so I say, okay, great. Please provide approved prompt in Markdown. And now we'll get back the prompt. We're going to then go through, feed that back into ChatGPT and see what it says. Let's check back on here. Meanwhile, this point here, we have the landing page structure all been implemented on the architecture. You can now run the development server to preview the landing page. Okay, cool. Let's have a look here. So we just say should have. I don't think we've got any pages here at all. So what I'm going to say is, please provide a README file. How to run this. In details on installation. Interesting. Okay. I'll leave that to run. We've got this prompt now. We'll come back to ChatGPT and we'll say, we enhance the prompt. Please provide your feedback on this prompt along with suggestions for further improvement. Kind of like an arms race between the AIs. It's kind of cool. So I reread it and it will come back. And what it will come back here and say is that this prompt was good, but there's some opportunities to improve it. Or it'll say, you know what, I think that's pretty good. And at that point, then that's probably the point when I would go through and read it in some detail and be like, is it getting everything that I want? But what we've got is we had a prompt that was good and we made it more robust. It's got some suggestions, refining examples and tutorials. Yep. Enhancing best practice. Okay. Incorporating some suggestions. Okay. So I'd say great. It was on the wrong LLM there. So I'm just going to go this and see if I can. Okay. Here is an advanced prompt. Let's suggest improvements. And then we'll sort of see what we come back with. But saying it's kind of good enough, it's added some stuff here. I have found doing this process will get much better results than you will just running something through once. And you do get to a point where you've kind of got these things that they're constantly trying to help. And so they'll do stuff, but then when they've given it another chance to do it, they'll come back and they'll say, yeah, I should look at doing this. Okay, great. So let's say you can ship this today without full note of agent instruction prompts. I've seen for doc writing. Okay, great. But okay, please implement your improvements. We'll come back to the next seconds. And over here, now we should have this right from the point where it's running. So we've got a README file now. We were supposed to clone the directory. We're supposed to run npm install. And there is no package.json file. Okay, so which is a bit of an oversight. And we'll just feed that error back in. We've got a package. And now I have a package.json file. And then we'll be able to run. Okay. Now I'll install everything. And we'll get our modules all good to go. And then what we're going to do is just run this and see how it looks. And then we might issue a few commands to go and do some stuff. Okay, let's see what we get out of that. Okay, so you're seeing some stuff. It's got some errors. Now you can set these agents up to do all this stuff automatically. I'm not doing this today because I want to show you guys the whole process. And I also wanted to show you giving it what's a really generic prompt and kind of going and doing it. But you can set this up to go through and look for the errors and find those and keep working through stuff. Okay, so now we've got our course. We asked for a website for a course, and now we've got a website that gives a course. The styling's not that great, but you know, we pretty minimal work. We got something that's quite cool. Just to recap, we started with like a completely blank slate. We ran npx. So back to this guide here. We ran npx create spark in it, and that set up all our agents here, or all our different types of prompts, and then the orchestrator started running and split stuff out. Now, it didn't do a perfect job, but also we were pretty kind of lazy in our initial prompt. And so if you gave it some more clear instructions, you would actually probably get it running the whole way through. So I'm pretty happy with that. We've got to a point where we've got stuff is running. We could keep working through. We could then refine our prompt and make it better to get like more accurate results out next time. But effectively, we've got a workable solution of very little work. And you sort of saw how little time I was spending on this actual coding window. I want to show you guys a little bit more now about the rules that sort of are behind all this, because I think that's helpful to know. We'll just jump in and have a look here. So you'll find in here there's a few files that are installed in this .ru file. So the top level one is these ru modes. Now these ru modes is the kind of is the important stuff. And there must be a way to make this wrap around. I should figure that out first. These instructions are the ones that you will see across in here. So if I come into this ru code here and I look at, jump back up to the top, and I look at the different types of prompts, this code, which is in this ru modes, is what you'll see in here. And so if we jump to documentation writer, we can come in here and we can see that prompt, which is in here. And this gives us that really detailed type of prompts of what we want to do through all this, which is really cool. And we could take that and we could feed that back into the LLM, like I showed you before, and sort of say, what do you think of this? What improvements would you make? There is some specific language in here that is, which is custom to these ru modes that you need to be aware of when you're writing this stuff. And so you can see in here that we have probably the most complex one is this code one, because it's got all these different types of areas. So let's have a quick look at this, because this is literally the most complex one out of everything. Okay, so you're following the Spark the workflow for this. Each block must be less than 500 lines. Each function must be less than 50 lines. Don't repeat yourself. It's got some clear stuff. The subtask assignment using new task. So this is really important because this is the bit where it tells it, okay, I'm creating some stuff here, but I need to know when to create subtasks. So that's what is telling it to do that. It's got a XML style invocation template for telling it when to use tools. So when we look at the up in the rules here at the file operations, for example, what you'll see here is that this it's not showing in the mark down very low. This is the format in which you've got to put this to have this actually work in this area. So insert this what you can see here is that this is insert content. Ru code will read through these files and it will look for the XML, and from that it will kind of know what to do. So there is a little bit of work involved to kind of take to go from this concept of I want to create an orchestrator that does a particular thing to customizing that thing to what it is that you want, and then actually creating some stuff that goes and does that. But there's an example, there's a template there, so you can leverage off that. So you can run this command, you can jump in, you can then run all this stuff, and you can sort of see what you get out. Now, what I want to kind of highlight to you guys is that if you decide, for example, that you want to run a different type of workflow, you might equally test that using the same technique. So customer support, you could set up some agents that do some stuff. You could set up some more senior ones which actually pause, and you tell them to pause and ask a human what to do. And you can kind of have it go through and design some stuff for you that's relatively complex. This is not quite how you sort of see agents done traditionally, but you can, of course, be writing code at the same time as you're doing this. You can be looking at databases. You can be doing a whole bunch of stuff. What's particularly cool about Roo code, and Klein as well for that matter, is that they just this up. They have, as part of what they can do here, the ability to use the browser. So when they're running, part of what they can do is actually they run the whatever it is that you're doing. They'll take a screenshot. They'll look at that screenshot, and then they'll say that's looking good, or that's not looking like quite what I expect. So these agents can actually use your browser and kind of read stuff. And then from that, you can get some fairly, you can actually get them to sort of do a bunch of the testing themselves. So the goal in all this, of course, is to get to a point where you have as much of this being done autonomously as possible off a single prompt. And the goal is to set up kind of all of your prompts here that will enable you to do that. The benefit of this, or the kind of the goal in all this, is to set up stuff so that if you've got different types of tasks being done from coding, you might be doing a particular type of coding, or you might be doing a particular type of function, and you can customize your rules to sort of suit what you're looking to get out. So that's pretty cool. We got a functional app with minimal effort. We didn't spend a lot of time kind of going through it, but we also wasn't the goal. Now, I want to change gears a little bit here now, and one of the things we talked about is the fact that we applied different models to different levels of prompts down here. And you might ask, why would you do that? Why wouldn't you just use the best one, whenever it's available for whatever? And the answer is cost. So if we look at the cost of some of these things, if you look at the cost of Gemini 2.5, and I think Gemini 2.5 is pretty reasonable. I think Gemini is pretty reasonable. I think it's the best out there that I've sort of seen so far. But the cost will range from Flash, sort of light is 0.075 cents. Gemini Pro 2.5 is $2.50 when you start getting above 200,000 tokens. And if you're doing anything remotely seriously, you will get above 200,000 tokens in no time. And so changing the models changes things an awful lot. If you are looking to use GPT, that's more expensive than Gemini. And again, the cost changes an awful lot. So GPT 4.0 mini or nano, relatively modest, 4.1, pretty high. And when you get into some of the thinking models, it gets really expensive. So if you're trying to get a piece of work done and you want to have someone do some architecture stuff that you need done, by all means, give it the highest power thinking mode, because you want the horsepower at that point. You want the AI to have gone away and really thought it through and have done some good stuff. If you're looking to have something to read some files in and load them up into memory, then just get a cheap model to do it, and you can do that. So cost becomes important. Knowing what models to set up is important. It's as simple over here as setting up your configuration across here. And in this case, I've only got a few different models set up, but I can go to my settings here and I can add in a new profile for OpenAI GPT-4, create that, and then I can assign that to OpenAI and GPT 4.1. Let's just edit that to be 4.1. save that. And now I can come back into my models here and I can assign different assign them to the different setups. And once it's assigned, it's good to go, and it will just stay that way forever. So then it comes back down to how well does your orchestrator actually jump between the different types of modes. And the answer is that it's pretty good, for the most part. But if you're anything like me, you'll sit and you'll chuck a command in and you'll watch it for a little bit and you'll sort of see what comes out. And then you'll have a look at your rules and you'll go through that process of refining the rules as you go. So that's the stuff to be aware of. The other thing which is also worth being aware of is that you can run a model for free. Well, there's such thing as free, but you only pay for hardware and electricity. And some of these models are kit apps, I have to say. So if you look at Qwen 3.8, it's really, really good at coding. It's only got a small context window, so you can't go in there and do a full application from scratch, like just throw in something at Qwen, because it will run out of context window. But with what I'm showing you here with RuCode and with all the stuff, you use the orchestrator to split stuff up, and you don't need the full context at each point in time. And so you actually can start to use some of these local models to do stuff more cheaply, which is fantastic. You do need a decent machine. Like you're looking at like a chunk of, this is the minimum, like this is the bare minimum. If you have that, then you'll get there, but you're going to be not loving life. But if you have a decent machine and you have some of these models downloaded, you can run some pretty grunty kind of stuff on some of the high-end things and avoid some of these horrendous costs that you might find otherwise. And this is going to become one of the things which is kind of crucial around making this sort of work in scalable. So that's the end of the kind of conversation around the RuCodes. As I said, this video will be there. I'm going to jump into some MCP stuff now, which will sort of show you the next level. But just to recap, we were using Visual Studio Code. We installed RuCode. We then went and we ran this Spark model to get our rules in there. The Spark model gave us a whole bunch of areas that we could run through, specify pseudocode architect refine complete. And when you give that an instruction, the orchestrator will, out of the box, will give you some pretty decent results. And then it's up to you to configure this to have the best results based off different types of costs that you're wanting to achieve. And of course, come back into this to configure this to get rules which are more suited for you. DevOps is an interesting one, right? Like we can actually start to automate some of your DevOps and stuff. So what we're going to have a quick look at now is come back and have a quick conversation around MCP, which is the kind of the missing piece in all this. And we've got half an hour left, so I'm going to spend 15 minutes on this, and then I'll throw it open for questions that we'll sort of jump back in as we need to. But MCP is a standard for connecting AI assistants to systems where data lives. You can effectively think of MCP as being a series of tools that your application can go and run. And out of the box, people are doing MCP servers that they could be simple little tools, that are quite sort of handy for stuff. But there's also some tools out there that are really kind of serious stuff. And so where programming is getting to is that people are putting together a toolkit of things that go and do different kind of tasks. And that is powered through MCP. And what I want to, I'll come to it in a second, but what you can do here is anything as simple as accessing all of your kind of standard stuff like your G drive, your email, your local files, search, all through to your own custom MCP servers. And we'll kind of skip over this because it's not so interesting. There are some really cool servers out there. So obviously the toolkit that you build up to go and do whatever you want to do will depend on what it is that you're doing. You know, if you're a carpenter, you won't have a forklift. But if you're doing stuff at an enterprise level, you probably have all these tools in your stable, and you'll kind of get to know how to use them all. And the tool sets are growing, and they're easy to access. So let's have a quick look at a couple of really cool tools. And just before we do that, I'll show you guys where to find these tools. So all you need to do is type in MCP server, and you'll get back a bunch of stuff. And you can come in here and you get a whole bunch of just an insane amount of servers, and there's more every day that do pretty much everything. And when I talked about the different types of tools, like some of them are let's look at some simple ones. I saw calculator in here. There's just a calculator, so you can just give it that. It's like giving it a little hammer. Some of them is some interesting stuff that you can actually interface to your Arduino through this. So why this is important is once you're talking to these things through an agent up here, you're issuing natural language commands, and then you're having all these tools down here go and do stuff. But the rules become important as to sort of telling you how that's set up. So what we have is, let me just see if we've got this up here. Yeah. What you have here is that you will set up a series of tools that you kind of want to have whatever access, and then you'll just you'll say, this particular mode that I've got, I wanted to have access to these tools, and you configure that when you're configuring your system. And what you've got at that point is you've then got a researcher mode that then has access to all these tools because you've configured that when you set the system up. And so what the kind of the interesting part right now is to figure out what tools are useful, and then to figure out how to link them up. And effectively what you can do is start to build up a kind of a workflow that suits whatever it is you're doing, with a set of tools that suits whatever it is that you're looking to do, and refine that. And then if you've got some work which is involved in working through particular things. So for example, if you're doing DevOps, you would set up some stuff in here. You would set up a DevOps kind of rule, and you would give it a bunch of DevOps type of tools. You give it access to AWS, you'd give it access to whatever it needed to do. You'd give it access to AWS Azure DevOps. And you would then go and have on here a bunch of tools. The instructions, let's see if we can find one which is got. Okay, so here we go. So these are the kind of the things that you can do with the Azure DevOps: is get a project, get a team members, query pipelines, pull requests. There's a bunch of stuff you can do just through issuing like commands to these tools through MCP. So it becomes incredibly powerful. But people that aren't doing DevOps wouldn't put that toolkit into their setup. But people that are, or as you build stuff out, you build out the toolkit to get more and more powerful. So that's where MCP becomes insanely cool. I'm going to show you a couple of tools that I really like, and I'm going to show you why, and then we'll throw it open for conversation. And I'm actually going to switch back to client because I haven't got this running on Rufo at this point in time. By the way, the community guide has a section on MCP. And it has a section on, I think it's got a section in there on setup as well. But if you go through that and you see some stuff that's is missing, let me know, and I'll try and get stuff in there. Okay, so some cool MCP servers that I really love. Context 7. So imagine that you are you're this architect over here, right? And you're doing some stuff, and you get to a point where you've done it, and you want these coders to go and do it, but you want them to work off the latest documentation. And so what you would do is you would say to your coding agent here, and let's look at that folder structure here. Okay, using context 7. Context 7 wants you to look up the documentation relating to Superbase, and I'll look up not all documentation related to Superbase, and place it in /docs/ text edit /Superbase.md. Now, what you do is you doing these things is you build up your rules to do this automatically, so you're not having to go and do this. But this is now saying client wants to use a tool on the local context 7 MCP server. It wants to use the library name Superbase. And if we just come and have a quick look at the context 7 MCP server over here, context 7 is up-to-date documentation for LLM code editors. So it's got all these things here. And the context 7 MCP server has 2 tools available, one of which is to resolve the library ID. So you give it a name, it will go and look up the ID. And then the other one is to get the documentation that goes with that. So when I come back in here and I say that I want you to do all this stuff, the first thing it's going to do is it's going to use that resolve the library ID. So it'll go and call that tool, and it will then say, I've got the library ID. And oh, by the way, for this, because I'm just looking up documentation, I would switch to a super cheap LLM, and that would be what I would have for my documentation looker upper. And then I'll go and look that documentation up, and it will put it into my docs folder over here, and I'll approve it to go and do all that shit. And now what we can see is in a second, here we go, we've got our tech stack documentation coming out here. And this is now providing the documentation that the code needs to go and do stuff. So what we've done here is we've got an intern, a low cost model. We would sort of say when we were setting up our rules, if you're doing the stuff, go use context 7, which is this, in our case is the we give it a tool we wanted to use, and that tool is going to go and look files up, use that thing to look it up and put it in this location. So we start to specify what this intern does, and then it goes and does whatever it is that we need to do. So you think of any kind of coding work that you do, or any kind of work you do at all, in fact, and you just work through the process, and you're like, can I use a tool to do that? Can I get one of these things to go do my work for me? And the answer is maybe not completely, but certainly a lot of it can. So yeah, context 7 is super cool. It's one that I recommend that you guys use as soon as possible. The reason being is that context 7 avoids LLMs from hallucinating. So if you have loaded your documentation into your documentation stack, and your coding agent knows about it, you can get away with a cheaper LLM than you could otherwise, because you don't need to have as much knowledge because it's got good documentation. So again, you can reduce your cost by doing this. The other one that's interesting, and we're not going to cover this in any detail, but Claude Taskmaster is apparently pretty cool. I haven't used it myself, but it's something that will split stuff up into tasks in much the way that the stuff that I've shown you with Recode today is. So if you're on Claude and you want to have a crack at doing this type of work, have a go with Taskmaster. It's the same kind of thing. You just different sort of interface and different sort of setup. That's kind of helpful. Sequential thinking is really interesting as well. So sequential thinking is an MCP server that provides a tool for dynamic and reflective problem solving through a structured thinking process. So hang on a minute, this is pretty handy. Breaks down complex problems into manageable steps, refines and refines thoughts as understanding deepens, branching alternative path of reasoning. Right, so this will give you a step-by-step process for running stuff. And we have sequential thinking installed here. So we might say, using sequential thinking, please design a process for customer service for the plumbing industry. I don't know. I'm just making stuff up. Put the documentation in /docs/plumbing. You have full featured set of digital services to work with. I don't know. And this will then go away and be like, okay, I need to go and design a customer plumbing service. I reckon I'm going to take 5 thoughts to do that. It'll kind of sit and work through it. Now, in this case, I've given it a cheap model to work with, and that's kind of dumb because in this case, you want it to have something more full featured to work with. So actually, let's change this and give it something a bit more grunty to work with. And now it will, I might have issues with the, okay. Let's go back to that. But now I'll go through and think all that stuff through, and it will actually write a plan up in here, and we'll get to the end of that and sort of see what the plan looks like. So sequential thinking is really cool. It has this kind of process where it'll tell us what it's come up with. And normally you would sort of follow this through a bit more, but I'm trying to get through a bunch of stuff. Okay, now here's our process. And we've got a kind of a generic-y process that we've just designed using this, which is pretty good. And we would go back and kind of do that. So this is useful for a whole bunch of reasons, but sequential thinking, super cool. The most useful one of all is memory though. So memory is about maintaining context across sessions. So one of the problems you've got when you run these sessions, and this is what I show you here, is that you have this context window that everything sits in, and the context window gets passed around to these modes. So this packages this up, and it doesn't get full context. It gets like what the orchestrator thinks it needs to have, and the orchestrator doesn't always get that right. So when you pass the context in here, you've got to kind of say this is what you need to get to make this work. This memory MCP server though makes that a little bit more overt, in that it will actually remember project details across your sessions, maintains understanding of the code base, tracks decisions and their rationales. So the way that RuCode works under the hood is you've got this list of I don't know what they're called, those different kind of prompts that I set up basically, and then it has this list of things where it tracks progress, it tracks decisions, and it tracks the project context. And the memory bank kind of works across all of this. Now, it's not particularly sophisticated. It's just passing some files around, between these things. But it's better than the out-of-the-box sort of setup of what you've got for memory. And what's particularly cool is it remembers product details across sessions. So this is quite helpful for getting your systems to work more accurately. And I still have some playing around with this to sort of see where it breaks and where it doesn't. But you can basically see, like I said, well, effectively you get these set of tools that you need, and you're like, okay, what tool do I need to do my job? Where am I falling down? Where am I having to do work? Is there a tool out there that lets me do this stuff? And chances are that there is, because there's so many MCP servers out there, and it's not that difficult to write your own either. So if the tool doesn't exist, you can take one and you can sort of change it to write your own stuff. And we'll be covering some of these tools in future sessions to sort of show people how to actually use this in more detail. But there's some really cool ones here, like this 21st century magic, which will build really nice user interfaces for you. When you start looking at kind of the amount of different tools that you've got and what you could put together, it's like, oh wow, it kind of clicks that then you can be like, I'm designing a process here that will scale across whatever it is I'm working to do, and I just now need to kind of chip away at that and grow it and understand it. And so this comes back to that whole process of coming up the curve here. You know, I've shown you today, this is what you can do with this sort of stuff. You need to then actually work through it and sort of see where it's not working. You need to interface to the other people that are doing it and kind of say, where are you doing? So, you know, collaborating with people is really helpful. And what you'll find is that there's a wealth of information out there. It's quite confusing though to go through all this stuff. You know, it's quite confusing to figure out how to set up root code and do all this stuff. Because it is a kind of complex little beastie. But that's where kind of this part comes in, where you join a community like this and you can work through it. So hopefully that's been helpful. I'll pause there just so people can ask questions. And of course, I do want to do the usual thing at the end of just going back and reflecting on kind of where to from here. But did people have any questions on that? I've talked to an awful lot of you guys. Anything come up you want to ask? You'll see there's someone with a hand up. Can't see who it is though.
Hey David, it's me, Adrian.
Hi, Adrian.
Hey David. Fascinating and very interesting. Thanks. A little bit technically over my head, but I've been trying to soak up in between the lines. I'm just curious as to whether what you're talking about here with this sort of orchestration process and the sort of multiple agents leading up to human, to different scales of that would apply to some of the things that, we've been talking about in the sort of creative space, design and that sort of thing, as well as code in a similar way.
I believe so. I haven't. That's where my mind's gone as well. And I think the short answer is yes, but I need to do some tests, see how it actually works.
Because it does seem to map to a lot to what we've been doing in our tests at the moment.
Yeah.
It's a very interesting space, sort of not necessarily replacing people, humans, but working out a framework to change the way they work, assisted by AI. Yeah.
I think it will map through. And I guess the bit that I'm curious to start to try out is that when you start building out, things for whatever the task is you're doing, like exactly what this looks like. And I think it would obviously depend on the process. But there'll be some things you can't automate and some things that you can. What I can say in general is that everything's going to move to the right in some way, where people who previously worked at this level will now be able to work at the next level up.
That's right.
So that's kind of what but I know that it will. I just don't know exactly what it looks like yet.
Thanks.
Yeah.
Could I see that last slide again, the one customer service one?
Yeah, sure.
If I screen grab it.
What was it?
Thanks. Yeah, got it.
Around.
Gonna consider that for our chat for next week.
Yeah. Any other questions? I am open to, obviously, if you guys want to jump on Discord, feel free to do that. Post questions there. I'll keep talking. If you guys have questions, jump in, because this is sort of your time to ask. That's if there isn't any, I'll happy to keep chatting away. I might just turn my camera back on as well so you can see me a little bit more. Cool. So what else we got? If you want to learn the stuff a bit faster, we're starting to put some of this stuff into custom sort of areas where people can. Some of the stuff is a little bit more kind of mapped out. So what we've got in the community guide is pretty good, but there's more detailed instructions coming here. Hackathons are a really great way to learn this stuff. So jump onto that if you want to practice. There's one coming up at the end of the month. We're going to run these every month as well because they're quite useful. If you see anything here and you're like, oh, this is great, but I kind of can't, I don't know, it's all a bit hard, reach out. Happy to chat. And there's different ways I can support you. But yeah, happy to work with you guys in whatever capacity. So feel free to do that. Jump onto the website as well. Like jump on and check out the videos. I will put this video up here because this has been recorded. There is another one of these sessions coming up, but I will put this up. Discord is a great way to get involved as well. And I would really love if people have enjoyed this and you're like, oh, this is great. I would like to help. There's different things we could get you to work on that would kind of start to get you to a point where you, this is the best way to accelerate yourself, in my opinion. But up to you guys, of course. Hopefully, this is a lot of information, that we're going through here, and we're going through it at pace as well. So I guess, not necessarily you don't have to do it here, but if you've found this confusing, drop me a message, or if there was stuff that you didn't like, I'm probably going to run some sessions in the future which are more at a beginner level, just sort of as I'm learning stuff, I'm teaching it as well. So that's kind of part of it. But I do want to make sure that people get information that helps them. So let me know if there's stuff that you would like to know. And particularly if you found things confusing, let me know, because that will help me tweak things. Our goal, obviously, is to be interesting and clear. Sometimes I'm sure we're not interesting and unclear, but hopefully we're sort of somewhere in the ballpark. Also, particularly probably the most helpful thing you can do for me is if there's stuff you want to do, which is more like in terms of letting me know where the session landed for you, that helps me pitch it. In this case, we had about 15 people come on, and there's 12 have stayed for the whole thing, so that's probably about right. But you might have kind of come away from this being like, I know what's possible now, but I don't know where to start. If that's the case, then ping me and we can look at setting up some sessions that are a bit slower for those people. If you've enjoyed this, leave some feedback. It really, really helps me. We have a nice little community growing now. We're actually getting close to 1,000 people now across the different meetup groups that are running. And your feedback helps with that. So if you've enjoyed this, it's quite a bit of work to put these slides together. And I enjoy it because I learn myself as doing it, but it does help to get that feedback if you want to do it. The tech stack stuff, I need to update this slide because the tech stack, the best place for you guys to go to get up-to-date information on the tech stack is actually to go to the community guide. So this is where everything is kept up to date. You'll find this by going to the website and then jump into the community guide. And then in the community guide, like I showed you before, there's a section down the bottom where, where the tools section is, and the index to that will give you the the tech stack. The tech stack is broken down into sort of foundational infrastructure protocol, stuff like that. Best place to start is to start with the foundational tools and sort of build your way up through that. And you'll also find in here a bunch of kind of live coding books and stuff. So there's some good resources there, but I kind of need to update this this slide here because whilst it's still largely accurate, there's a few different things we've done since then that make this a little bit. There's a bit more stuff in here. We ran a couple of weeks ago. We ran a session on mobile app development, and we were using Flutter for that, which I was really impressed with. And that used Dart. So there's things like that that aren't in this tech stack.